Hello, welcome back to our channel. Now we are going to discuss about kinetic theory of gases. A few problems previous years Eamcet problems. Look here. The first problem is two vessels separately contain two ideal gases. One is the A, another one is the B, and they have given temperature is constant, means same temperature. If the pressure of a gas A is 3 times the pressure of the gas B, under these conditions the density of the gas is B. So just look this problem. The question is we have to find out the ratio of molecular weights of the two gases. Temperature is constant, they have given the pressure and given densities are like this. Look at this paper set, you can get more clarity. So we can use the ideal gas equation here. Ideal gas equation, PV equals to mass of the gas by molecular weight into RT. Here instead of mass we are writing volume into density. So PV equals to Vd by m. After that finally, see, look here, Pm by D equals to constant, means that is a relation between pressure, molecular weight and density relation. So Pa by Pb equals to Ma by molecular weight of gas A by molecular weight of gas B equals to density of gas A by density of B. Then Ma by Mb equals to, we are writing, they are giving that relations. So Pb by Pa into Da by Db. So finally we have to substitute, but density of gas A is 2 times of the density of gas B, and pressure of gas B A is 3 times of that gas B. After simplifications, molecular weight of gas A by molecular weight of gas B equals to how much? 2 by 3. So simply you should remember this formula, Pm by D equals to constant under constant temperature. So then simply we can substitute these values. Finally we can able to find out the ratio of molecular weight of gas A to gas B. Then come to next question. See, second question, look here. An ideal gas, if the masses of all molecules are doubled and their speeds are halved, speeds are reduced to half and that masses are increased to twice, then the ratio of initial and final pressures of the gas is, so simply we can go through the pressure and RMS velocity relation. Pressure equals to 1/3 mn by V. V bar square means that is the velocity square. So from this what we are writing, P1 by P2 equals to mass of the gases, remaining all are constants, M1 by M2 into V1 squared by V2 squared. That dash is representing, this is the RMS velocity. Finally they have given masses is increased to twice, means instead of M2, M1 by M2, 1 by 2 is ratio. And this is decreased to half, means 1 by 2 whole square, means I have written 1 by 4. So finally what is the ratio? 2:1. So pressures ratio P1 by P2 equals to 2 by 1. The main thing you should remember here, M1 by M2 equals to V1 by V2 whole squares. Those are the RMS velocities. Then come to third problem. The given data is, it's very simple question. Look here. The specific heat of helium at constant volume, how much? 12.6 joules. Means they have given CV value and they have given capital R value. What we should find out from this? We have to find out the specific heat at constant pressure. Specific heat at constant pressure, how to find out this one? We can use Cp minus Cv equals to R formula. We can use Cp minus Cv equals to R formula. Look. But we want Cp, means Cp equals to Cv plus R. Cv value 12.6, R value 8.314. After simplification, Cp equals to 20.9 joule per mole per Kelvin. How much easy this answer, you look here. They have given, this is question number 2020 September 10th shift 1, they have given this question. Then come to fourth question. See, a gas has n degrees of freedom. A gas has n degrees of freedom. then the Cp by Cv is, look here these options. First one is n plus 2 by n, second one is the 2n plus 1 by n, third one is n plus 2 by 2n, like this. These options are there. But here the formula you should remember that Cp equals to n by 2 plus 1 into r, then Cv equals to n by 2 into r. These are representing degrees of freedom. So after taking the Cp by Cv ratio, what we are getting, n plus 1, n by 2 plus 1 into r by n by 2, or after simplification we are getting n plus 2 by n. So this is also a very simple answer, but you should remember that Cv equals to number of degrees of freedom by 2 plus 1 into r. And this Cv is the n by 2 into r. After doing this, you are getting this answer. Then we can go through the fifth problem. Fifth question is very easy. How many rotational degrees of freedom does a rigid diatomic molecules? They have given one figure. Energy can able to store along the y-axis and z-axis. It is not possible along the x-axis. So what is the answer? Answer is the 2 degrees of freedom for rigid rotational bodies here. Then come to next question. That is the question number 6. It is also very easy. See, an ideal gas at temperature T, pressure is the P, occupies a volume is V. If its temperature is held, means T2 equals to T1 by 2, we can take it. Pressure is doubled, means P2 equals to 2 times of P1, you can take it. What is the new volume? So which equation we have to use? We can go through the ideal gas equation. So what is that? P1 V1 by T1 equals to P2 V2 by T2. Then after simplification, we want V1 by V2, volumes ratio. V1 by V2 equals to P2 by P1. You know that P2 is 2 times of that first one, 2P by P. And T1 by T2 is half of that one. After simplification, we are getting the ratio V1 by V2. Instead of V1, we are writing V. They have given in problem. Finally, V2 equals to how much? 1 by 4 times of that V. So, V is reduced to 1/4 of that one. Then we can go through the next question. Question number 7. This is the formula only. This is the formula and related to concept questions. Look here. The question is mean free path of molecules in polyatomic gas is independent of. Look here, mean free path. What is the formula? 1 by under root 2 pi into d square into nb. So first option is what? Number of density of the molecules, volume of the molecules, temperature of the gas, and gas constant. First 3 it is depending, but it does not depends on the universal gas constant. So mean free path molecules in a poly gas is independent, means not depending on gas constant. So fourth option is right. Then we can go through the 8th question. This is also concept question only. Look here. All gases deviate from gas laws. At what? You know that at low pressures and high temperatures, all gases are behaving like a ideal gases. But opposite to that one they are asking. See, all gases deviate from gas laws at what? Low pressures and high temperatures. No, it is wrong. It is following that. B1, high pressures and low temperatures. So this is the right answer. This is theoretical only. You should remember that. Then our next question is 9th question. Look here. Question is what? Two gases. See, two gases A and B are contained in two separate but otherwise identical containers. Gas A consists of monoatomic molecules each with atomic mass is 4 units, whereas another gas is having B consists of a rigid diatomic molecules each with a atomic mass is 20 units. Here also we can go through the ideal gas equation. Before that, VRMS we have to use, not ideal gas equation. VRMS equals to, what is the formula? 3RTA by MA. TA belongs to temperature of this one. We have to substitute all values. Finally, you are getting the temperature of gas B is how much? 1500 degree Kelvin. See, this is the relation between them. When they are giving in centigrade, we must convert into degree Kelvin. We should add that one with 273 degree Kelvin. Then come to 10th question. 10th question also very easy. Look here what they have given. An ideal gas is placed in a tank. At what temperature? 27 degrees centigrade. The pressure initially 600 kilopascal. 1/4 of the gas is then released from that, means 1/4 of the molecules are reduced, and the thermal equilibrium is established, means then what happens? What will be the pressure of the temperature? If the temperature is how much? 327 degrees centigrade. Here you can use the ideal gas equation. P1 V1 by N1 T1 equals to P2 V2 by N2 T2. P1 they have given 600 kilopascal into V1 by N1 into 300. This side is the P2 V1 by volume is constant, only same tank, but that is 1/4 is released, means remaining is how much? 3/4 of the T2. After simplification, finally you are getting that P2 equals to 900 kilopascal. P2 equals to 900 kilopascal. Then we can go through the 11th problem. 11th problem also very easy, based on the RMS velocity here. See, the question is, an ideal gas in a closed container is heated so that the final RMS speed of the gas particles increases by how much? 2 times the initial RMS speed. So V1 equals to V2 equals to 2 times of that one. Initial temperature 27 degrees centigrade, then the final temperature is how much? Simply we know that direct formula for this, that is V equals to under root 3RT by M. Remaining all are constant, we should write it. V RMS by first RMS speed by second one. V RMS by second one is 2 times of that first one. Directly I have written this. Under root T1 is 27 degrees centigrade, means we are converted into Kelvin. So under root 300 by T2. After simplification, T2 equals to, once again I should express it in terms of degree centigrade, that is based on the options. Suppose all options are in degree centigrade, means we can give that answer is also in degree centigrade. If degree Kelvin means directly we can say that 1200 degree Kelvin. Thank you everyone. Please subscribe my channel.